Hi, I'm Mary, and this is another magical math moment. In this video, we are going to be solving radical equations, which is super fun. So in order to do this, we want to isolate the radical first. So in this first problem, we are going to start by subtracting a 2 from both sides. That leaves us with the square root of 3x minus 5 being equal to 4. After you isolate the radical, you want to kind of undo this radical that's here. So this is a square root. The inverse operation is to square it. So we're going to go ahead and square both sides. The square root and the square cancel each other out. 4 squared is 16. From there, it's not so bad. We're going to add 5 on both sides, and we get 3x is 21. Divide by 3, x is 7. Now remember, with radical equations, you always have to check your answer just in case it does not work. So we have 3 times 7 minus 5 in the radical plus 2 equals 6. Simplify everything over on the left. The square root of 21 minus 5 plus 2. Keep going in the radical here. The square root of 16 plus 2 equals 6. The square root of 16 is 4. Remember, when you're simplifying radicals just like this, you're only considering the positive root. Students don't like that rule, but that's kind of how it works. 6 does in fact equal 6, so x equals 7 is a valid solution. Sometimes they like to write the radicals instead with rational exponents. So we're going to start by isolating this binomial, which is being raised to the 1/3 power. We're going to do that by adding a 9 on both sides of the equation. We then have 4 times the 2x plus 6 to the 1/3 equals 12. Next, I want to divide both sides by 4. This leaves us with 2x plus 6 to the 1/3 equal to 3. This is the same thing as the cube root, so if it makes you feel better, if you want to rewrite that as the cube root of 2x plus 6, you can do that. The other way to approach this is to raise both sides to the reciprocal exponent of 3. You'd be doing the same thing over here. It's just another way to think about it. Here that will cancel. You've got 2x plus 6 equal to 27. From there, it's easy peasy stuff. Subtract your 6. 2x is 21. What's with all these 21s? Divide by 2. 21 halves? Okay. Life is messy sometimes, so that's fine. Let's do the check and make sure that we are correct. We have 4 times 2 times 21 halves plus 6. Ooh, can I fit all of this? To the 1/3 minus 9, that should equal 3. I didn't plan this out very well. That's okay though. So now we've got 4. The 2's cancel here. 21 plus 6 to the 1/3. And then the rest of it. I'm going to add 21 and 6 to get 27. Order of operations says that I have to do exponents first, so 27 to the 1/3 is the same as the cube root of 27. 4 times 3 minus 9 should be 3. Multiply. 12 minus 9 is 3. 3 equals 3. We're happy. This is a valid solution, even if it is a fraction. You know what, people? Fractions need love too. All right, let's amp it up a little. I've got the quantity x plus 3 equal to the square root of 4x plus 17. So we're going to go ahead and square both sides. This is going to give us x squared plus 6x plus 9 equals 4x plus 17. Now, if you're wondering, what in the world did you just do over here? Remember, when you've got a quantity squared, don't just distribute the power in. That's no good. Every time you do that, a puppy dies, and nobody wants a dead dog. So take the first number in here, or the term, and square it. X squared is x squared. Then look at the next term, 3, and square it. 9. The middle term keeps the sign of the middle and is twice the product of the two terms. So x times 3 is 3x, double it, 6x. Once we have that worked out, I know this is quadratic, so I'm going to set it to 0 by bringing everything over to the left side. Now you want to have your squared positive. Your squared term should be positive. So in the event that you move the x squared over to the other side, you would want to multiply everything out by a -1. Okay, so once we're here, we have to think of the factors of -8 that add to 2. So how about 4 and -2? When you multiply them, 4 times -2 is -8, 4 minus 2 is 2. We know from the zero product property to set each of these to 0 and solve. The hope is that when you're in Algebra 2, you should be able to do that part in your head. If you still need to write it, equals 2, that's fine, but it's always kind of nice if you can go right to it. It saves you a little bit of time. All right, we got to check both of these. So we're going back to the original equation. So -4 plus 3 equals the square root of 4 times -4 plus 17. -1 equals the square root of -16 plus 17. -1 equals the square root of 1. This, friends, is not true. We are sad. That is not a valid solution. Let's try the other one. We've got 2 plus 3 equals the square root of 4 times 2 plus 17. 5 equals the square root of 8 plus 17. Oh, look at that. 5 is the square root of 25, which is a true statement. Hooray! So x does in fact equal 2 in this equation. These are kind of weird, so I thought it might be fun to do another one. Ooh, that looks even worse. So let's see what's going on here. I've got a radical isolated on the left, and then I've got a radical expression with just a random -1. So we're going to go ahead and square both sides. Over here, x minus 8, no big deal. This side is where it gets strange. So remember, in the last thing, we're going to use that shortcut to multiplying out a binomial times itself. I've got the square root of x plus 3 being squared. So I'm going to write that, and then we'll simplify. Some of you might be able to do this part in your head, and that's awesome. The middle sign is negative, so we're going to keep that. I'm going to multiply 1 times the square root of x plus 3. And then don't forget, I have to double that. So I'm going to put a 2 in there, multiplied by that 1. At the end, I'm going to take the last thing that's in our binomial, in this case a 1, and we're going to square it. Now, if you put it in as -1, it's still just going to give you a positive 1 there. All right, let's keep going. We got x minus 8. Here, the square root and square cancel. I'm going to make that pretty and make it -2 times the square root of x plus 3 and plus 1 at the end. All right, we have to isolate this radical to get our answer. Let's move the x over. Wait a minute, it's going to cancel on both sides. I'm left with a -8. Don't lose your minus sign there. This is 3 minus 2 rad x plus 3 plus 1. I'm going to go ahead and combine my like terms over here. 3 and 1 is 4. Remember, when you're combining on the same side of an equation, you don't change signs. Just combine what's there. 3 and 1 is 4. Okay. Next, we're just going to go ahead and solve this. I want to get the radical by itself, so we'll subtract a 4 on both sides. That gives you -12 is equal to -2 times the square root of x plus 3. Next, I'm going to divide both sides by -2, so I get 6 is equal to the square root of x plus 3. I want to get rid of this radical, so since it's square root, I'm going to square both sides. 6 squared is 36. And then the square root of x plus 3 being squared is just x plus 3. All of that to get an answer of 33. Let's hope this is a valid solution. So we're going to do our check over here. I have the square root of 33 minus 8. That's going to be equal to the square root of 33 plus 3 minus 1. Don't forget that negative 1's outside the radical. Okay, so this is the square root of 25. It's equal to the square root of 36 minus 1. 5 equals 6 minus 1. That is true. Hooray! So our solution, x equals 33, is valid and correct. I hope that this helps you a little bit with radical equations. Thank you so much for watching. Please feel free to like, share, and subscribe. Thank you for joining me for a magical math moment. I look forward to seeing you in the next video. Bye.